C8051 serial communication. Timer overflow. This is the baud rate generation circuit. How do you set a baud rate of 9600 bits per second? If S mode is 0, T clock is 0, R clock is 0, and SM0 and SM1 is 0 and 1. This is the clock path. This clock would be 9600 times 16, in order to get 9600 at this point due to the divide by 16 block. The clock here would be 9600 times 16 times 2, which is 307,200. 307,200. This is called the timer overflow rate. It is the number of times the timer overflows in 1 second. This is how the timer runs in 16-bit mode. The 16-bit counting registers are made up of two 8-bit registers. The timer can be configured to 8-bit mode. In 8-bit mode, only TL1 is counting. TH1 can be set to any desired values. When TL1 counts to FF, the content in TH1 is loaded to TL1. The counting then continues. If TH1 is set to a larger value, overflows occur more often. The setting to 8-bit mode is done in the T mode register. These bits are for setting timer 1. These bits are for setting timer 0. Let's just look at the setting for timer 1. These 2 bits sets the mode of the timer. Setting the bits to 1 and 0 set timer 1 to 8-bit mode. Let's set the other bits to 0. Therefore, T mode is set to 20 in hex. Let's set TH1 to FD. Observe how often the timer overflows. Let's find out how often the timer overflows. TL1 is loaded with the content in TH1 when the timer overflows. From FD, the count goes to FE, and then to FF. From FF it goes to 00. The timer has just overflow. TL1 is loaded with FD again. The count continues. The timer overflows again. There is an overflow at this point, and at this point. This is how often the timer overflows. The number of overflows in 1 second is called the timer overflow rate. So what is this overflow rate? Let's find out how much time it takes the timer to overflow. Let's assume that the system clock is 11.0592 MHz. This is the clock path. The clock is divided by 12. The result is 0.9216 MHz. The 0.9216 MHz clock has a period of 1.085 microsecond. The timer content increments every 1.085 microsecond. It takes 3.255 microsecond for the timer to overflow. The timer overflows every 3.255 microsecond. The number of overflows in 1 second is 1 second divides by 3.255 microsecond, 307,200. Therefore, with a system clock of 11.0592 MHz, and with TH1 loaded with FD, the overflow rate is 307,200. Let's look at the baud rate generation circuit again. The timer overflow rate is 307,200. If S mode is set to 0, the clock at this point is 307,200 divides by 2. This is the clock path if T clock and R clock are both set to 0. The clock at this point is further divided by 16. With SM0 and SM1 set to 0 and 1. The clock at this point will be 307,200 divides by 32. That give a baud rate of 9,600 bit per second.